I welcome to all the course of refrigeration and air conditioning. In the last class, we are completed the chapter 1 air refrigeration system. Today we are going to start the chapter 2 simple vapor compression refrigeration system. Let's to know the content of this chapter. The first is introduction, then advantage and the disadvantage of vapor compression refrigeration system over air refrigeration system. Then mechanism of simple vapor compression refrigeration system. Then the types of vapor compression cycles. The 5 types are here. The first, the cycle with dry saturated vapor after compression. The cycle with wet vapor after compression. The cycle with superheated vapor after compression. The cycle with superheated vapor before compression. The cycle with subcooling of refrigerant. Let's start that introduction of. In the introduction, all of you know that in the air refrigeration system, you are used air as a refrigerant. But in this now you are going to start the vapor compression refrigeration system. This is a improved refrigeration cycle which use the fluid instead of air as a working substance. So why you are using the fluid instead of air? Because the air having low heat capacity. For that reason, you are using the refrigerant like ammonia, sulfur dioxide and carbon dioxide which freezing point temperature, if you take an example of the ammonia, the freezing point temperature is minus 77.73 degrees Celsius and the boiling point temperature is minus 33.34 degrees Celsius. And if you see the carbon dioxide also, the sublimation point means that boiling point and the ice point freezing point temperature minus 78.46 degrees Celsius. And if you see last is the sulfur dioxide, the boiling freezing point temperature is minus 72 degrees Celsius. So here you observe the freezing point near equal to minus 70 degrees Celsius means that we can up to you can go at least minus 60 degrees Celsius means the high range of refrigeration. So which is not possible if you are using the air as a refrigerant. So in the vapor compression refrigeration system, you are choosing the refrigerant such the freezing point temperature is minus 70 degrees Celsius so that we can maintain high range of refrigeration. Then here in the you observe in the open air refrigeration system that air direct contact to the room, but here in the vapor compression refrigeration system does not leave the system but is circulate throughout the system, alternatively condensing and evaporating. These systems belong to general class of vapor cycle where in the working refrigerant undergoes the phase change at least during one process. So in a one process the phase will be changed. Okay, then the working substance is circulated in the system which is alternately evaporate and the condense that it undergoes a phase change. Here the input to the system in the form of mechanical energy to required to run the compressor. Hence, the system is also called as mechanical refrigeration system. As you are giving the mechanical energy as an input, that's why you are telling mechanical refrigeration system. Let's to know the advantage and the disadvantage of vapor compression refrigeration system over the air refrigeration system. First, the advantage. It has smaller size for giving capacity of the refrigeration. So why it is smaller size? Because if you see the pressure ratio, the air refrigeration system, the pressure ratio is high because the suction pressure is the atmospheric pressure. But here the pressure ratio is compared to less. For that reason, small size compressor and the condenser or other device you are using. Second, it has less running cost. As you are using the small device compressor, so obviously it will affect to the running cost. Then it can employed over large range of temperature. As just now I told, if you taking the ammonia as a refrigerant, the freezing point temperature is minus 77.73 degrees Celsius. Means we can maintain the large range, means that we can maintain minus 60 degrees Celsius. We can maintain the refrigerator temperature minus 60 degrees Celsius, which is a very large range of temperature. Fourth advantage, the coefficient performance is quite high. All of you know that the coefficient of performance that is equal to the heat refrigerating effect by work done. So here you are using the ammonia. If you take a ammonia, the refrigerating effect means heat carrying capacity is very greater than greater than the air. If you example, I am giving an example. If you taking ammonia, the heat capacity in the form of gas 2.175 kilojoule per kg Kelvin, and if it is a liquid form, that is 4.74 per kilojoule per kg Kelvin. So if you here you observe the ammonia having high heating capacity than air. The heat carrying capacity of the air is 1, but the ammonia heat capacity is 2.175 in the gas form. So it will carry more heat. It will carry more heat, so that your coefficient performance will be increased, because the coefficient of performance is directly proportional to the refrigerating effect. So what are the disadvantages? Here the initial cost is high. Second, the prevention of leakage of refrigerant is the major problem in the vapor compression refrigeration system. So all of you know that ammonia is a flammable gas and it will harmful to the human beings if it will inhale. So by accident, if the refrigerant leak to the surrounding, it will affect to the human beings. Means in the industry area, if the ammonia leak, so it is a flammable gas, it will be burn or damage the industry. For that reason, this is the major disadvantage in the vapor compression refrigeration system. If you see in the air refrigeration system, if air will be leak, that will not harmful to the industry. Okay, but in the vapor refrigeration system, you are using the refrigerant, which is a flammable, so it is a disadvantage on the vapor compression refrigeration system.